Hey guys, we're going to review all of the various homework questions. Now, if you're thinking to yourself, Mr. Erico, I don't need to see all of the homework questions. I only need to see number 13. You know what? That's great. Skip to somewhere else in the video. Because what I'm going to do is I'm going to go through them in order. Okay? Now, what I thought I would present right at the beginning, though, is the following. A list of sort of the steps that you ought to follow for each of the various questions, right? So if you got stuck, right, it's entirely likely, for example, that number one, maybe you didn't, I don't know, draw a diagram. I've been telling you the whole year, right? Draw a diagram. Draw a diagram. Always draw a diagram. And if you don't, then you're probably going to get stuck. All right, the next thing that you got to do as you're trying to solve the problem is decide if it's an isolated or a non-isolated system, meaning do you start with delta E equals 0 or delta E equals work? If there aren't any non-conservative forces there, then you're going to go with delta E equals work. On the other hand, if it seems like it's only like gravity or springs, then you've got a situation where it's an isolated system, right? Only conservative forces act. All right. Next thing that you'd want to do is decide what types of energy exist at various positions. So you'll see me do that for each of the questions. Your options are pretty much just these three, right? If it's moving, there's kinetic energy. If it's higher than the lowest position, then there's gravitational potential energy. If there's a compressed spring, then there's elastic potential energy. All right, and then plug in and solve. All right, that's the part where there's algebra. And then lastly, if you do get stuck, like ever, go look through the notes packet. There's probably an example similar to the one that you have a question about. If you look through it, you may discover there's none exactly like it. That's normal. I'm not going to give you the exact same question in your notes that you're going to do in your homework, right? It's got to require a little bit of extra thinking on your part if you're going to learn something new from it. Number 13 is clearly not an isolated system. They tell you that as this sled's going across the frozen pond, there's a coefficient of friction. Now, obviously it's ice. Okay, so the coefficient of friction is relatively small, but it's there, right? It does eventually stop sliding. You know that from experience. Things don't actually move forever on ice. So we're going to have to go with our non-isolated system model, right? Delta E equals work. All right, whenever we see delta E, right, that's always final minus initial. The final energy, well, let's draw a picture here, right? Here's the ice. Let's say here's our sled, and it goes a distance d and comes to rest like over here somewhere, right? Okay, so at this initial position, it was moving that away, right? In its final position, it's not moving, so it doesn't have kinetic energy. It didn't go up or downhill, so it doesn't have gravitational potential energy. There's no springs, so actually the final energy is nothing. Okay, that's it. It's brought to rest by friction, so our final energy is zero, nothing. All right. The initial energy, though, is kinetic energy, right? It says it's given a kick, it slides. All right, for the work, friction is doing work to bring it to rest. Our formula for work, remember, is force times distance, or rather F dot D. Because it's a dot product, friction, since it acts in the opposite direction of the displacement, will do negative work. So you'd better have a negative sign there. The friction force, well, we've got fun. That would be your normal force upwards. That would be your gravitational force downwards. You know enough about Newton now that I would not expect you to have to show a lot of work for that, right? Normal force equals gravitational force when you're on a flat surface and nobody's like pushing up or pulling downwards on it. So that means the friction force is just going to be mu mg. Okay, and then that times a distance is going to give you the work done by friction. So negative mu mgd is going to be the work done by friction. All right, so then I guess what we're going to end up with is negative 1/2 mv squared equals negative mu mgd. At this point, the algebra to solve for d ought to be pretty straightforward. Now, if you want to show yourself something extra with this question, you could go through, figure out the acceleration using Newton's laws, and then use kinematics to get the distance it travels. You'll discover that you get the same answer either way. All right, don't stop here with this question, by the way. If you just end there, you didn't finish it. Finish it. Solve for d. Okay, I'm not going to do that last step for you. You can do the algebra. Thanks.